much. It's a great talk on variant data types. The stage is yours.
Yeah, thank you. Yeah, thanks. Yeah, my name is Aihua. I'm working for Snowflake. Yeah, actually, today I'm going to talk about the new variant data type. Yeah, here's today's agenda. First we are going to give a brief introduction on what is a variant data type. And then after that, we're going to dig into the more technical side, like encoding and decoding, and then like shredding. Hopefully, you're going to catch up what is like shredding. And then I talk about the metadata, like for a variant. We're going to catch up. We're going to collect some like metadata, which will help to like pruning related to variant. Later, we're going to talk about what is the current roadmap for variant, what is the current status for variant, and lastly, I'm gonna, if you have any questions, please let me know. Yeah, the first, what is like variant data type? If you are new to this area, you may want, yeah, why we need to introduce a new variant data type? Yeah, actually, like in Snowflake and or like Redshift, actually we already have like similar concept. Snowflake has like a variant for a long time, and Redshift also have like super for variant data type. So this is like to store like semi-structured data. Like for example, similar to like what JSON does. So it's kind of encoding the schema inside the data type. Of course, later probably going to give some examples. You will understand what exactly variant it is. And with variant, like if you change the schema, like for the data, it's going to handle pretty friendly, pretty nicely. For variant data type, you can also store like nested data inside, and also you can store like different data types. For example, you can store int, you can store string, or you can store object inside the variant. And lastly, like it can help to optimize storage. Later, you can find out why what that means for optimized storage. So here are some like use cases. Well, actually, like when you run ChatGPT, you may find like some other use cases. Here are some of the examples. So let's say you want to collect some data, from logs or from streamings. Like the incoming data actually may not be well formed. Yeah, some users actually approached to me. They were saying, "Oh, like since I don't have such kind of use cases, my data, it's like column 1, column 2, column 3." I was saying like, yeah, if that's the case, maybe you don't need to use a variant, right? But in reality, that's not the case. The data actually varies a lot. So now, why we introduce variant in Iceberg? As I mentioned, different engines may already support variant data type. Like in Snowflake, we support variant, and also super, right, in other engines. And those engines actually have different encoding. Like it's not compatible. If you want to move from one engine to another, then you have to like reload, right? Like encoding and decoding, and then load into another engine. Iceberg, of course, as a standard table format, you can avoid such kind of like reloading, right? So that's a purpose. Now, if we introduce a variant into Iceberg, you can also avoid the similar data reloading. The second is, as I mentioned, a variant can support like semi-structured data. Now, with such kind of like a support in Iceberg, you will find out you can handle like a wide range of semi-structured data. Like just as I mentioned, like you can you don't have to let's say create and have like very complex logic when you handle data. You feel like if your data is this data have column 1, column 2, another data is column 3, column 4, right? You have to have your own logic and create a separate table, right, to handle that. But with variant, you can have like very uniform a schema. So later, yeah, probably you can find out with some examples. Yeah, here are some example. For event 1, I kind of like created this on purpose. For event 1, event type, the type is the value is login, which is a string. But on event 2, the event type is 100, which is an integer. So the purpose is like you may want to have a schema evolution, right? Let's say at first you want to have a string type, but later I find out, oh, I maybe want to save some space or something. I want to change that type to integer, right? Now, if you don't use a variant, you probably have to create a separate tables or logic, right, to handle that. When you ingest string type, you can have to go to this table. If it's an integer, go to a different table. But with variant, you can stuff them together into one column. And also, as you can see, like in event 2, we add additional columns, additional fields, like version, for example. In event 1, actually, you don't have that. That's also fine. You can work with that. Basically, you are delay the parsing, during the query time rather than like during the ingestion time or write time. To make them more complex, look at the third example, third one, which is like error code. That's also very typical, right? Very normal, like in some cases, you may receive an error response rather than event 1, event 2. That's completely different, it's different schema. That's also fine for variant. You can also put that into variant column. Now, after you have this data and store that into variant column, but for the user, it's going to be very simple. Basically, you kind of like create such kind of like, this is more like Snowflake syntax, but some other engines may have like similar syntax. So you create the Iceberg tables, and then you want to ingest JSON, right? For example, which is semi-structured data into that variant. You can like, which can support like parse JSON and ingest it into that table. And when you are doing the query, you can use like event type and then convert that to string. And also like you can have this is like array, right? So you can have like tag 0 equals commedia, like to do some like filtering. So for end users, actually it's kind of like just a normal SQL queries. But of course, there's a lot of like details or technical challenges to implement variant. But for users, it should be like pretty straightforward. Now, yeah, let's dig into like more technical side, which is like variant encoding, decoding. By the way, this is like it's mentioned in the spec, but I want to call out and explain more details about spec. That also hopefully can help you. Like some other engines are implementing this, and some languages are implementing variant. So hopefully we can clarify use this talk. So for variant, there are probably like most of the data types, Iceberg data types, can be supported in variant. For example, primitive type, including such as like int, timestamp. Comparing to JSON, which is also one type of semi-structured data, right? Data type. Comparing to JSON, variant is more rich. Like for example, JSON cannot encode timestamp into string, but for variant, it will tells you it's a timestamp. And also we can also encode array as well. Now for that array, actually, it's not just like regular array, which is a string array or something. It can be, you can mix like int, string, or anything inside the array. Or it's even can be an array itself. It's kind of nested array. The third one is like object, which is a collection of key values. The keys actually has to be string. That's kind of like different from normal object. It has to be string. And the value can be anything. Technically, like it's a variant. And then it can recursively include primitive arrays on object. Yeah, so here is a little bit more deep on how we encode the variant. So first, we're going to have a metadata, which is to tell you, which is like to basically tell you like the version of variant encoding. So currently, it's a version 1. But in case we find any issues, right, we're going to evolve into version 2, version 3, then you're going to use this field. The second is it's a sorted field, which is well, actually the metadata is to hold a dictionary of strings. Do you remember, like we just mentioned, for object, we can only have string as a keys. Now that keys, the string keys, actually will be encoded in the dictionary, in the metadata. And then later in the value side, you use index rather than encode the strings. That is like to save spaces. Like if that kind of like keys are repeated, right? You can reduce, spaces. Yeah, so this is like a header, and then after the header, that's kind of a dictionary. So first, like the size of dictionary size, and then there's like an offset, which is like pointing to the strings in here. So just like tell you, offset 1 is pointing to the first string, offset 2 like second strings, and we also have like offset n plus 1, which is pointing to the end of the strings. It's just like for engines, it's kind of like currently you may not use that, but we figure out the engines may use that to do the further optimizations. For example, to help speed up the search of the strings. So that's why we kind of like add that. Yeah, you may not need to use that. After metadata, it's coming like with the variant. That's kind of like actual variant, actual value encoding. So the layout is it's kind of like this. There's a basic type and then value header. Like this value header will be different based on different basic type. We have like 4 basic types. One is primitive, second is short strings, and object and arrays. Now, if it's and after that, it's gonna be the data area. But of course, you may not need data for some of cases. For example, if it's true, yeah, maybe let's go to the next slide. Like the data may not exist. For example, if it's null type, or if it's true or false, right? You only need the header. You don't need the data. But if for some other case, let's say if it's int 8 or something, then we're gonna encode the data after the header. Yeah, this is like a primitive data type, primitive variant encoding. Yeah, actually, this is like pretty straightforward. Now, another case is like is a short string. Like string is also primitive types. Like we can also encode as a primitive. I cannot remember what is type ID, but it's gonna be a length plus the string. But if the string is short, let's say it's less than 64 bytes, then you can use the short string format to do the encoding. Now with that, the basic type is 1, and then you can encode the length in the header. Then after that, you can encode the strings itself. Now compared to primitive encoding, the benefits is like it's gonna save a little bit. It's like the length, right, in the data. So that's gonna like save some spaces. Now third one is object. Yeah, object and array are a little bit more complex. So yeah, for object, the basic type is 2, and then we're gonna have like is large, which is like to tell you like is this object large or not. If it's small, then it's gonna like the number of elements, it's gonna use like 1 byte to do the encoding. If it's large, then it's gonna like use 4 bytes. We think that's gonna be sufficient, like to do the encoding use 4 bytes. And also, there's like ID size, which is as we just mentioned, right? We will not encode the string, the key in here, but instead use the index into the dictionary. So that is that integer, index, which is like index into the metadata. Another is like offset size, which is like offset into the actual data, encoded data. Similarly, we're gonna have an offset n plus 1, which is to like help you to, which is point to the end of the list. Hopefully, it can help. It can be used in certain scenarios to do the speed up. For array, it's kind of like similar, but as you can see, there's no ID. So yeah, it's large, which tells you whether we're going to use 1 byte or 4 bytes to do the encoding. And offset is like kind of like indexed into the actual data. Yeah, so that's basically the basic encoding, decoding for variant. To summarize a little bit, for variant, actually it supports the majority of Iceberg types. Second, like the decimal storage is pretty efficient. You can use like as little as 4 bytes to store the decimal. It supports decimal 4, decimal 8, like for decimals. And also for strings, it has 2 ways to do the encodings. One is short string. One is a regular, primitive type encoding. Yeah, another one is like integer. We support like int, 1 byte int, 2 byte int, etc. So depends on for each column, right? If it's all less than, you can fit in 1 byte. You don't have to waste, use integer to do the encoding, like 4 bytes to do the encoding. yeah, lastly, like, as we mentioned, we're gonna encode the keys, object keys, in metadata. And then we use index instead of actual string. So that if that keys are repeated, right? So it will reduce the storage. Yeah. When we are working on the spec, we do evaluate different encoding, and we figure out, that's probably like more efficient. Yeah, next is like shredding and reconstruction. First, like, what is like shredding for a variant? So far, like, basically, what we are talking about is like a variant going to be encoded into a variant binary, into a like value binary and a metadata binary. That's like two binaries. But we can do more optimization. This is more like optimization. So now without this like a shredding, when you are trying to access a certain field, now you have to load the whole variant, the whole value, and then decoding, and then parse the data, right? So that's you have to do. Like what a shredding does is, let's say you have certain fields which are commonly accessed. Now you can extract those fields into a separate columns and store them. So with that, if you want to access that, you don't need to load the whole variant columns or variant data. You just access that fields directly. So that's kind of like a shredding behind. Now, the benefits of shredding is it's kind of like maybe obvious. You can do like a little bit pruning and also reduce data access, right? You don't have to load the whole data. And actually, like for the storage layer, you can also optimize the storage because, for example, let's say Parquet, right? If those data are like, for example, kind of unified, it's an integer, right? It has its own way to do the optimization. But if you like store them as binary, probably it cannot do anything, right? It's just like store whatever you tell them to store. So that's kind of like another side effect. Now, how do we do the shredding? So basically, first, the shredding is per file. For each file, we are applying the shredding. So when it's across the files, actually the shredding may be different. Let's say, in this file, event type, use that as an example. Event type is a string. On the future, like event type becomes an integer. Now, so it's possible in the file 1, it's going to be shredded into string. On file 2, it's shredded into integer. So it's kind of like based on like each file, what is the type inside that field? We're going to do the shredding. Second is we're going to like how you're going to choose the fields for shredding. As I just mentioned, probably it's going to be like optimal. What kind of fields will be commonly accessed, right? Then you do such kind of a shredding. So let's say, this 10 fields will be accessed very frequently. Then I'm going to shred those fields. But the problem is like during write time, you don't know like which fields will be frequently accessed, right? So that's kind of like a challenge. So a spec actually doesn't call out, how you're gonna shred. That's kind of up to the engine to implement. For example, the engines may have some like configuration, right, for the users to say, oh, I know this 10 fields will be accessed frequently. I'm gonna configure this 10 fields. That's also possible. But for Snowflake, actually, the implementation is like within a file, we access the patterns of each variant, to try to find out like common fields, and then choose, let's say, top 10 or top 100, and then shred. But of course, that's not the commonly used fields. But it's really up to the engine to implement. And third is like within a file, let's say event type may show up in one variant, or it may show up as a string or as an integer, right? But we can only choose one a shredding type, let's say string. Now, what about it's an integer type? Now, if it's an integer type, then we'll consider it's untyped. We're gonna encode that into binary. We're gonna leave that as untyped column. But if it's it matches the shredding type, for example, it's a matched like string type, then we're gonna shred as a typed column. Okay, so now when it's array, actually that's gonna become more complex. Yeah, I'm gonna show you with some examples later. But for arrays, as we mentioned, we can support different type of element types. For example, it can be integer, it can be an nested array, or it can be string, or anything inside arrays. Similarly, we have to determine the element type to be shredded. Yeah, so here is kind of like a simple shredding example. Let's assume like we're gonna shred event type to string, event TS to timestamp, etc. So you can see for this variant data type, we're gonna have a column event type with value login, and event TS have a timestamp and email. But for the untyped, it's going to be empty because everything can be shredded. But for the second one, since event type is integer, it doesn't match the string type, right? So it will be encoded in the untyped field. It's going to be inside the remaining. So then for this column, you can see it's all like timestamp, and then when we store, it will be stored as a separate column. Yeah, let's take a further example. It's a simple like event variant column. And as a Parquet, as an example, you can see like this is without shredding. It's gonna have two fields. One is metadata, and one is value. In this case, it's all binary fields. Then, if it's shredded, then it's gonna be schemas like this. Remaining. If we cannot encoding some fields, right? It's going to be in this value fields. It's called the untyped value field. But if it's typed, then it's going to be encoded in here, in event type. Yeah, so this is kind of to encode a string. Now, if it's int, right, it's going to be encoded in this value. Yeah, similarly for array, it's a little bit more complex, but we are encoding with a list schema. Now, it's shredded, but when you try to access, if you want to access the whole variant, right, then you need to do the reverse reconstruction. So that's kind of like the high level, how to reconstruct the variant. Basically, for primitive, you kind of choose from like typed value and see which one exists, and then extract the value. For objects, it's kind of the same thing, but the difference is like you have to combine, because for object, some fields may not be shredded. Then it's going to be in a value. You have to combine both. But for like primitive and array, it's kind of choose one of them. That's kind of the difference. Now, let's come into the metadata. So metadata, as you may know, it helps to do the file pruning, right? We are like for regular Iceberg columns, we collect null values, value counts, low bounds, and upper bounds, especially like bounds, which can help you to prune the data. Kind of similarly, we try to collect metadata for variant fields. Like for example, if it's like location, longitude, right? We try to collect the stats for that and say, oh, this is a range. And then if you have kind of similar, this kind of like queries, you can use the metadata to skip the files. Another benefit is like probably you can answer the aggregation functions like this, without scan the files. You just like query, get the metadata, from manifest file and return this. So what we are trying to propose is, for subcolumns, actually we call it fields. Actually, Snowflake calls subcolumns, but we call it fields. For each field, we're going to collect a lower bound and an upper bound, and save them in a variant, and then encoding as a binary. So that actually is to make it compatible with Iceberg v3 metadata format, because yeah, as you can see, actually we use binary for lower bound and upper bound. Yeah, for metadata generation, so it has like 3 cases. Let's say if in the file, if all the values match shredded type, let's say, oh, it's all string. Now, for that case, we can collect lower bound and upper bound. But how about like if it's a string and integer? For that case, actually, you can't collect the bounds. So, for this case, you have to kind of like skip collecting. But if there's like some values are missing or nulls, for this case, actually, metadata still helps. You can combine with null counts, and you can also answer, say, oh, this is all the values are within 1 to 10, right? You can still kind of answer similar to the first cases. So for this case, we also collect metadata. Yeah, here to give the updates on the current status on the open source and what is kind of like future work. So basically, currently, we are spec is already kind of like there, and we are trying to finalize the spec. Currently, we are waiting for 2 reference implementation to close out the spec. And variant type implementation, this is already complete. And shredding, actually like metadata, it's in progress. A couple of things are in progress. Variant reconstruction and shredding are in progress. And there are a couple of integrations, actually, like Spark integration, hasn't started, and also some engines actually start to add the variant implementation. And on the Parquet side, we need to add variant logic type, which is like in progress, and also, as I mentioned, some reference implementation are in progress as well. Yeah, and here are some of references. This is more open source work, so if you want to contribute, you can also reach out to the community and participate in discussion. It's not finalized yet, so you can still have your opinion in. Yeah, so I think that's yeah, pretty much it. So it's yeah, a lot of slides. It's a little bit rushed, but let me know if you have any questions.
Yeah, thank you very much for the talk. I think we still have 7 minutes for questions, so still a little bit of time. Yeah, I'll start with you. I think Han was up first.
Hi there. Is there any estimates on timeline when this feature will be released? Is my first question. And for customers who are using the V2 spec of Iceberg, we are storing as a JSON string. Would there be an easier way to migrate from V2 to V3 Iceberg? And then is there any indexing support for these variant data type would be there?
Okay. Yeah, actually, for the timeline, unfortunately, I cannot answer that question. Yeah, actually, the good news is like, the community is pushing forward on that. I cannot promise any date on that. Initially, we were saying like in April or May, but it's still going on. It's kind of like I cannot promise anything for open source. Yeah. What is the second question?
So for the V2 one, right? So the customers who are storing data as a string JSON, is there a easier way to transition from V2 to V3 without rewriting the entire tables when the V2 to V3?
Well, if it's JSON, yeah, the question is like how to migrate to JSON, right? Yeah, but like this is not compatible. So you have, if you want to use a variant, you have to like, yeah, reloading the data actually into variant column actually. This, remember that's an example, pass JSON, right? You have to like load that. It's kind of like a different encoding. So yeah, you have to do that.
Any easier way, maybe building metadata indexing or just re-indexing the metadata?
No, actually, that will not work. Actually, it's completely a different type, right? JSON is yeah, a different type, so yeah, I don't see a way, to support that. Yeah.
And just one last question. So for updates made to the variant field, right? So for especially merge on the table, are they going to be stored in a positional delete files? How is that going to be implemented? Updates.
You mean for variant, right?
Yes, that's right.
For variant, that shouldn't affect variant column as yeah, yeah, I don't see.
So for a lot of updates we are making, right? So we don't want to like comment, maybe you want to write to a log file and then come back to data.
Yeah, well, that question I may have to think of like what is like interaction with merge on read. Yeah, I don't see that connection, but let's maybe like follow up offline on that.
Perfect, thank you.
Yeah, I don't see the connections actually.
More questions? Here we have.
Hi. So I noticed that there are two different type IDs for Boolean data type. One for the true value and the one for the false value. So so for shredding the Boolean data types, does it mean that it would result in two columns?
Yeah, well, actually, yeah, that's a good question. That's a good observation. So actually, it will be in the same type, Boolean type. Yeah, yeah. When it's encoded, it's it's 1 and 2, right? Just like to save space. But when it's shredded, it's going to be in the Boolean column type. Yeah.
See, thanks. So encoding is based on the type ID, but the decoding or shredding is based on the actual type.
Yeah, 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 yeah. That's right. That's right. Yeah.
Hi. So in Iceberg v3 spec, there is a column called unknown as well. So how is that different from variant?
That's actually like variant. I think it's like unknown. It's just like which you don't know, but like variant is kind of like the actual type, which is kind of like encoding semi-structured. I think it's not related. These two. I'm not sure if anybody has more context on that.
So for completely unstructured data, would you recommend variant? Like if you have completely unstructured data for ML or such use case, would you recommend variant? And
Unstructured, you mean like something like an image or something?
Exactly.
Oh yeah, this cannot for image cannot be loaded in like variant. This is like for semi-structured data.
Okay.
Yeah, yeah.
And for the shredding part, does it happen with the first record of the file, or does it happen on the basis of all the records of a file? So let's say first record has string, but everything else is integer.
Yeah, that's a very good question. Actually, it's really up to the engine. For example, you can choose the first row, for example, right? I see the first row, it's a string type. I can use string type. But of course, that may not be efficient, right? Let's say the first one is string, the rest is integer. You are still use string to do the shredding, right? Then it's not efficient. So probably it's better to kind of aggregate. The best is like, I scan everything and find out the most common type, right? And then decide it's a shredding type. But it's really up to the string to do that, yeah.
Okay, we have time for 2 more questions. Maybe one here.
Do you have a rough estimate on how much savings in terms of storage and also query performance if we switch from like a raw JSON to variant type?
Okay, yeah, that's a good question. I don't have the numbers for storage. I guess it's also really depends on like the data itself, right? I don't have the numbers, but for the query performance, we're probably gonna release some numbers later. But actually, Spark has like for initial variant data type, they release a number. It's kind of like a few times, 5 times faster compared to JSON. Yeah, yeah, that's kind of like, yeah, we're gonna release some numbers, in the future. Yeah.
I have one last question here, and then I think we can take the rest in the break.
Yeah, so I guess I'm confused why it would be faster than storing string in JSON, right? Because you don't get columnar compression benefits if you do not shred your column, so you still have to scan every row. So it's most of the saving coming from...
Sorry, you're talking about storage or performance?
Both, right?
Both, okay.
So most of the savings, I would assume, is coming from not having to decode the JSON in string and be able to use the binary format, right?
Yeah, so regarding storage, because when it's shredded, right? It's kind of like
you can shred the strings too, right? Like you can just shred your strings and store the remaining untyped with a string.
I don't know the question. So let's say if it's JSON, right? You're talking if it's JSON, you try to save space. Like if it's JSON, I guess like it will be a large string, right? Then
Well, you can take the
I think maybe we can take that.
okay. Yeah.
To the break.
Sure.
The time is over. Thank you
Okay,
very
cool.
much, Aihua, for this great session.
Thank you.